we now need to discuss vectors, okay? And vectors are a very special class of objects in physics, but a very basic definition of a vector, we've already seen that it has magnitude and direction, okay? Another way to describe vectors is that a vector is an object that lives in a coordinate system. And it actually turns out that these definitions are equivalent, because if I live in a coordinate system, then that means whatever position in that coordinate system that my point specifies, then that distance from the origin to that point would be its magnitude, and then I can define its direction as an angle from some specified axis. Typically, we will define the angle from the x-axis, okay? Counterclockwise rotation from the x-axis. Okay. Now, in general, we can write vectors in this form. Okay, if I have a vector A, then it's going to have components. Now, we're initially talking about a two-dimensional vector. I can have three-dimensional vectors. I can have an infinite number of components with a vector. But for our purposes, the highest we will see is 3. Okay, we're only going to look at the x, y, and z directions in this semester, okay? But what my notation here is saying, okay, is that my vector A, my total vector A, notice I've put the vector symbol over this, is equal to some number, okay? So this AX and this AY just represent some numbers, okay? And these are what we would call the components of the vector. And so the first number, which typically goes with this I hat, and I'll explain that in a minute, is usually the x coordinate of the vector. So this one is the x coordinate. And this number represents the y coordinate. Okay. Now, how do I know that? Well, I've written a sub x and a sub y to denote that this is the x component, this is the y component. But more importantly, when we're actually using numbers, the x and the y are going to be denoted with this I hat and j hat. So I hat, j hat, anything with a hat, okay? Any number or any letter with a hat. Those are what we call unit vectors. Okay. Any letter with the hat symbol is a unit vector. Now, for our purposes, we're going to restrict our letters to I, J, and K. Okay? We're going to restrict our letters to I, J, and K. So, I hat is a unit vector in the x direction. J hat, a unit vector in the y direction. And k hat is a unit vector in the z direction. Now, what is a unit vector? Okay, a unit vector is simply a vector with a length of 1. Okay, it's a vector with a length of 1 in that specified direction. So I hat, okay, simply means a length of 1 in the x direction. Okay, so when I write a vector that looks like this, okay, if I have a vector that looks like this, the 3 here would represent my AX. 4 would represent my AY. Okay? What this is telling us to do is to take a length of 3 in the x direction. So I'm going to multiply this 3 by this unit vector in the x direction, and that's going to tell me to stretch my vector A 3 units in the x direction. Okay? It's going to tell me to stretch my vector 3 units in the x direction. Likewise, similarly, this is going to say take 4 units and stretch that in the y direction. Okay? So I'm going to have 3 in the x direction and then 4 in the y direction. Okay? And what does a vector actually look like? Well, a vector lives in a coordinate plane. So coming back to this vector, if I wanted to draw this vector, the first thing I have to do is define a coordinate system. And I'm going to label this as my origin. This is the x direction. This is the y direction. And suppose I have unit increments in this direction. So what this is telling us is to take a length of 3 in this coordinate system and then lay that across the x-axis. Now, a vector, okay, has a tip and a tail. Okay? So the tail is the part that starts at the origin, and the tip is the unit that we specify. Okay? Its actual coordinate. So this arrow represents 3 I hat. 3 units in the x direction. Okay? And then I want to draw a 4 units, a vector of 4 units in the y direction. Okay? So here's my 4j hat. Okay? Now, this vector, the total vector A, is the sum of these 2 vectors. Now, how do I add vectors? Well, I have vectors along my axes, so what we're going to do is relatively easy, but the thought process is also more general. Let's say I have 2 vectors, A and B, and they have these coordinates. The process I'm about to do would be the exact same to add these 2 vectors. Okay? And we will actually see that here in just a moment. But the process is this. Okay? Since a vector lives in a coordinate plane, I can move it around at will. I can shift its position as long as I don't change its length or its direction. So I can displace this vector, okay, and I can move it anywhere in my coordinate system that I want, as long as I don't change its length or its direction. So what I'm going to do is I'm going to take this vector, my 4j vector, 4j hat, and displace it such that its tail is at the tip of the 3i vector. And this is called the tip to tail method. Okay? And so if I displace this vector like this, I'm going to get a new vector. It's really the same one, but it's just displaced, of the same length there. And I no longer need that vector, but I'll redraw my axis. And so now this vector A is going to be the total distance from the origin to the new tip. Okay? So that is the vector A, right? I have 3i hat in the x direction. I have 4j hat. And when I add these 2 together, when I displace one of them such that their tail is at the other's tip, and I draw my new vector from the origin to the new tip, then that vector, okay, that object is my vector A. And A is the sum of these two vectors. Now, of course, the obvious questions are, what is the length of A? Okay, in other words, what is the magnitude? Okay, we obtain the magnitude of a vector by looking at the total sum of its orthogonal components. And what do we mean by orthogonal? What does orthogonal mean? Orthogonal means perpendicular. Okay, so that's why we use I hats and J hats and K hats, because if I have something in the X direction, something in the Y direction, and then something in the Z direction, each of those is going to be perpendicular to each other. Okay, and so what that means is if I have things that are perpendicular, I'm going to be able to use right triangles. So if I want to calculate the length of this line, all I have to do is use the Pythagorean theorem. And so what is the magnitude of A? The magnitude of a vector is going to be the sum of the squares of its components. Okay? The sum of the squares of its components. So I'm going to square my 3, and I'm going to square my 4. And remember that hats, the I and J hats, those are just unit length vectors. They just have a length of 1. They just specify the direction. So I don't include those in the magnitude calculation. Okay? And so in this case, I'm going to get 3 squared plus 4 squared, and 3 squared plus 4 squared, 9 plus 16 is 25. The square root of 25 is 5. And notice again, I don't have to worry about the plus and minus issue. Okay? Typically when I take a square root, I have the plus and the minus. When I am looking at magnitudes, magnitudes will always be 0 or positive. Okay? I cannot have a negative magnitude in length. I can have a vector that goes in the negative direction. Say I had a vector that went in both the negative x and the negative y direction, but the length of that line, if I stick a ruler across that line and measure its length, it will always have a positive measurement. So I never have to worry about the plus and minus when I'm looking at the magnitudes of things. Okay? So there's the magnitude of A. Now what about the direction? Okay? Typically, what we will do is we will specify the direction as the angle of the vector with respect to the x and y axis, okay? With respect to the x-axis. So what we're going to do is look at this angle theta, okay? We're going to look at this angle theta, and what we're going to do is determine the angle theta based on this right triangle. Now, the typical thing to do is to use the tangent function because you'll usually be given the actual x and y components. Okay? You could use sine or cosine since we have the entire triangle solved, but typically, especially if these numbers don't give you a nice round magnitude, okay? Like if your magnitude had to be rounded, which within the rules of sig figs, you would want to use whichever quantities you were initially given, and that will give you the most accurate measurement for your angle. Okay, so that way you're not incorporating rounding into your measurements. But in any case, if we use the tangent function, we can say that tan theta, okay, is here, and tan theta is the opposite over the adjacent. So this is going to equal 4 over 3, okay? And theta is then the inverse tangent of 4 over 3, okay? And you can plug that into your calculator, you'll get an angle. Okay, now you do want to be careful whether you're in degrees or radians. We're going to use both throughout the semester. Typically at the beginning of the semester we will use degrees. Later on we will use radians. but the bottom line is we would say that the vector A, okay, has a magnitude of 5, and the magnitude is found by the square of the sum of the squares of the components, square rooted, and then the angle is found through whichever trig function is available. Okay, so this would give its magnitude and its direction. In the next video, we'll do a little bit more with vectors. All right, see you then.